We're going to start our look at BGP attributes with a look at two attributes we discussed very briefly in previous videos. The first one being the origin attribute. You're going to see this attribute at the far right of the output of show IP BGP. Next to the number under path, you'll see the couple of letters I there. And by the way, I've set up another lab, so these routes are gone from the live equipment, so I'm bringing them to you on the board right now. We will be back on the live equipment very soon. Now, the actual origin codes are shown as well in the little origin codes row under show IP BGP. I would definitely have these down cold for the CCNP exams, and they're very straightforward, nothing confusing here. You either for the origin code have an I indicating an IGP via the network command, and that's how we got those two routes in there. E for EGP, that indicates a path that originated from an external gateway protocol. And question mark for incomplete, that's not as self-explanatory in iOS help. What that means is the true origin of the route is unclear because it was learned via route redistribution. Now in the best path selection process, it's I over E over question mark. Internal route is, IGP is preferred for source over EGP, and in turn EGP is preferred over an unknown source. So much more about this process later in this section. And by golly, look at this, it's later in this section. We're going to talk about the best path selection process here and the AS path attribute, which we saw briefly in the other video. The name is the recipe. It shows us the autonomous systems along the path to the destination network, including the AS the destination network resides in. The shorter the path, the more preferred the path during that best path selection process. The main purpose for the AS path attribute's existence is to help prevent routing loops, which we are always trying to prevent. And the way that works, if a BGP speaking router receives an update that has its own AS number in the path to a destination, the speaker says, something's wrong here, and that particular route is going to be discarded. Now in this example, and this was router 1 in our previous lab, the only AS shown in the path is the AS containing the networks, because the AS was right next to router 1, and you see under path 200, and it's followed by the origin code. On router 3, which was the router that actually contained those two networks, as we go down here you can see the only thing under the path was literally the letter I. Now we're going to run a lab that allows us to see the best path selection process in action. And I have pre-configured this lab. I'm going to show you why in just a moment, but they're all commands that we've used to this point. I know you know how to check adjacencies and to create those peerings, and I know that you know how to use the network command. So when you see everything I did here, you're going to see why I didn't show it on video. Now, first I'm going to show you the physical network setup. And for the sake of clarity and sanity of everyone involved, I'm not going to show you the physical interfaces and the switches in the BGP diagrams because these get pretty detailed and we don't need the extra drawings in there. And I strongly suggest you write this network out, and I'll show you the full network, physical network there in a moment. I know it's not all on screen, but I want to point out the networks to you. Routers 1 and 5 share an Ethernet segment 10.110/24. Routers 1, 2, and 3, the serial connection that we are so used to at this point, 172.12.123.0/24. And then finally, routers 2, 3, and 4 also share an Ethernet segment 172.12.234.0/24. I see we have an extra 0 in there. I'll get rid of that. And I urge you to write this one out because we're really going to be tracing some IP addresses and seeing why certain routes aren't going in the BGP tables, that kind of thing. So it's very important that you know exactly where all the IP addresses are. And of course, as always, I'm going to say it anyway though, the router number is always the last octet. I know you know that, but I'm telling you anyway. So go ahead and pause the vid if you need to and draw that out. And meanwhile, let me show you what I have already built. And with this many adjacencies and everything else, again, you know the network command, you know the peering command, the neighbor command, and you also know how to verify. So I didn't want to show you all that because we've got plenty of other stuff to show you, believe me. But you can see the only routers that share an adjacency inside an AS, an internal adjacency, are routers 1 and 2. And routers 3, 4, and 5 are in their own ASs. I've created a loopback on each one with the router number for each octet, and I have already advertised them into BGP. So at this point, router 1 has at least one entry for every loopback in our network. That should be true of every router, but it'll have multiple paths for the loopbacks on routers 3 and 4. And that makes sense because router 1, to get to say router 3's loopback, it could go either directly to router 3 through its eBGP adjacency, or it could go down through 2 and then over to 3, and it could even go to 2 and then 4 and then 3. It's always nice to have redundancy. And to get to router 4's loopback, router 1 could either go straight through 3, or it could go down to 2 and then down to 4. So it sounds like we've got some path decisions to make. And let's go ahead and bring up the live equipment. And what are we looking for next to the routes? We're looking for valid and best. And now you see why, because in the previous labs, we didn't have any multiple entries for any routes. And you can see here with show IP BGP, it's getting a little more complex, got a few more IP addresses thrown in there. And you can see router 1 has one entry for its own loopback, makes sense. And the next hop is all zeros, which also makes sense. It has one entry for router 5's loopback, also makes sense given the topology of the network. It only has one way to get there. And router 2, the next hop is 123.2, makes sense, that's the direct path. But we notice for 3 and for 4 that it has two entries. And you probably notice a couple of other little things over there, like some numbers that are there under a certain column and then not there. And that's particularly true of 123.3. It's not showing its metric, which should be 0. But under local pref, that's what I'm really concentrating on here. We see some entries that have nothing and some entries that have 100. But this is what we're particularly interested in right now, are these entries for 3 and for 4. And we see a valid and best. You can see here for 3333, the router has two entries, and it's chosen the path with 123.3 as the next hop IP address as the best and valid path. And for the entries for router 4's loopback, it's chosen, again, the path through 123.3. So watch those because, your eye can play tricks on you. I like to highlight them whenever I can and just say, okay, here's valid and best, because it's easy to think the first entry for the path is going to be valid and best. It's real easy, but that's not always the case. As you see here, it is the case with 4444, and then the path that wasn't chosen is under it. But here, the valid and best for 3333 is actually this one. So why? Why was this? Why were those particular paths chosen? Well, when deciding between multiple paths for the same destination, we have a pretty long-winded decision-making process. This is not 1 or 2 steps. And I would just have this memorized down cold for your exams. It's a very good idea. And here is that list. First off, the highest weight is always preferred. BGP weight, by the way, is a Cisco proprietary attribute. So the highest weight is going to be preferred. Then, if that's a tie, or there are non-Cisco routers involved, the highest local preference, that LOCPERF, that's preferred. If that's a tie, then the locally originated path is preferred. If that's a tie, then the shortest AS path is preferred. I'm not going to keep saying that's a tie, but I will say next up in the tie-breaking process is the best origin code. And by best, we mean I, then E, then question mark. The next one is the lowest MED, the multi-exit discriminator. And I know we haven't gotten to that yet, but we will. 7th step is an eBGP path will be preferred over an IBGP path. Then its lowest IGP metric to the BGP next hop address. As you can see, we're getting a little desperate here. I shouldn't say we're getting desperate as much as we're getting really, really detailed, because you're not going to see that many situations where the tie is all the way in the 8th or 9th or 10th step. But that 9th step being the oldest path, and the 10th step is being the path from the BGP router with the lowest BGP RID. So finally, we find a purpose for the BGP RID. Now, with that list in mind, on the next video, we're going to closely examine those selections that were made for the paths to router 3 and 4's loopbacks, because this really will turn a light bulb on for you. It's really going to illuminate some selections and some things that get done in labs after this. So take a deep breath. I know there's a lot of info in this one, and we're going to dive right in at the beginning of the next video and start looking at this path selection process in action.